Hello, and welcome to a digital lecture for Salt Lake Community College. This lecture will cover section 6.4 for Intro to Statistics, considering types of outliers in linear regression. Outliers tend to come with a misconception that they are values that do not align with the rest of the observed data. For example, interviewing many people in their 30s and 40s, as well as one or two in their 90s. The ages of the 90-year-olds seem to be outliers compared to the rest of the data. However, when talking about regression, outliers are a little trickier and can seem to, in some instances, strengthen results based on the position of that outlier. An influential point is an outlier that appears to invoke its influence on the value of the correlation coefficient or on the slope of the line. Another common misconception is that outliers should be removed when they are observed. If there are outliers in the data, they should not be removed or ignored without a good reason. For example, an error in recording that cannot be fixed, or learning that the data value was measured differently than the rest of the observations. Whatever final model is fit to the data would not be very helpful if it ignores most of the exceptional cases. Let's look at an example below of the influence outliers have on scatterplots. In this example, we have three scatterplots. The one on the far left has a correlation coefficient of -0.7 and a regression line of y hat equals 2.3 minus 0.84x. The other two graphs, labeled 1 and 2, have two different outliers that are circled. One outlier is in the top right, and one is in the top left. However, the rest of the data is the same as the data on the far left. For the first question, we have what would happen to the correlation coefficient R and the regression equation if the outlier in the top right were added. Well, in this case, since we see that this new point up in the far right does not really seem to align with my previous line, which would be somewhere around here, it seems like this is going to change a lot, and specifically R, which is supposed to measure how well a line fits the data, with an outlier like this in the top right, that's going to muddle the data. It's going to make the correlation coefficient less strong. It also is likely going to bring up this line ever so slightly. It is probably going to adjust this line and pull it up and down in this way so that I have a lower y-intercept and also a shallower slope to try to compensate for this new outlier. My response to this question is because the point is not in line with the current regression equation, we expect the correlation coefficient R to become weaker, closer to 0, and the equation itself to change, likely seeing a less steep slope and a lower y-intercept. For the second question, we're looking at the graph on the far right and asking what would happen to R and the regression equation if the outlier in the top left were added. Well, if I'm looking at this point in the top left and thinking about where the original regression line was, something like that, this point seems to be far closer to my original line. And because it actually is further away from the rest of the data and pretty close or on line with my regression line, it is going to strengthen the current regression line, actually. It is going to make R stronger, which means it's going to be closer to -1 in this instance, because it is a negative slope. And for the regression line, we likely will see a little bit of a change. Maybe we'll see the slope become steeper and maybe a higher y-intercept, but we don't expect much of a change because the point is already online. My response for this question is because the point is in line with the current regression equation, we do not expect much of a change with the regression equation itself. However, we do expect the correlation coefficient R to become stronger, closer to -1. If you have any further questions, be sure to review the example videos or ask your instructor.